Hello everyone. Thank you for joining us in the second part of our tutorial. So this tutorial is about Kubernetes props. So in the part 1, we discussed the theory part. We discussed what are props and why are they needed and what are the types of props. In this one, we'll do a hands-on on probes and we will do a lot of practicals. We'll create a lot of pods and a lot of probes so that it becomes easier for us to understand the concept, and also we get a habit of applying the concept uh, in a Kubernetes cluster. So if you haven't watched the previous video and you don't know what probes are, so maybe you should start with the previous video. Otherwise, we'll start this one. So first we'll go to the Kubernetes documentation. So I am at this part of documentation. You can simply reach here by simply searching probes in your Kubernetes documentation. And the first link is a small tutorial on these probes. If you scroll down, you'll find this liveness probe. This is actually an exec liveness probe. So we'll simply copy this. We'll go back to our terminal. I do have created one file here. So I'll firstly, let me remove this one. And now I'll create another one. Let me call it liveness exec.yaml. And I'll paste the content inside this. So you'll see that this pod name is liveness exec, and we are going to use a busybox image here. And if you look at the arguments, then we are going to use an sh command, and then this hyphen c. Hyphen c is basically used to say that the next argument, which is a string, should be counted as a command basically. So basically run this string as a command. So this will be run as a command. If you look at this command, you'll see by this we are creating a directory or a folder called temp/healthy. So we created a folder, and then for next 30 seconds it will be sleeping, so it will not do anything. And after that we will delete this folder. So this folder will only be present for the first 30 seconds, and after that it will be deleted, and then it will sleep for another 10 minutes. You can see that like we discussed, every container would have its probes. So inside the container, you should also ensure this indentation. So take care of this indentation. Inside a container, we'll have liveness probe and other probes as well. So what we are doing with this probe is we are doing this exact command that we have to do a cat on this directory. So if this folder is present there, then it will be healthy. And if it is not present there, then it will not be healthy basically. So for the first 30 seconds, we can simply say that it exists. So for the first 30 seconds, if this command runs, then it will give you a output basically. Otherwise, it will give you an error. Other than that, we have these additional keywords. So we'll also look into what are more features with liveness probe. These are the two. First is initial delay seconds. Like the name suggests, it would mean that like initial delay seconds is 5. So we would want to wait for 5 seconds before the first probe is conducted. So for the first 5 seconds, nothing happens. The container runs. And after that, we, for the first time, will do first probe. And period second basically means after every 5 seconds, keep on conducting probes. This basically means that wait for 5 seconds before the first probe. Period second basically means conduct probe every 5 seconds. Other than that, we have a few more keywords like timeout seconds. So timeout second basically means, for example, if we say 3 seconds, So it means that if the reply or if the response doesn't come for in within 3 seconds, then there is something wrong and the pod should be marked unhealthy. So this basically means time out for response response would be 3 seconds. Other than that, we have failure threshold. I hope I have written the spellings correct. If anything is wrong, we can look on it later on if some error occurs. So failure threshold basically means that if consecutively, let us say this is 3, by default it is also 3, so let's say it's 4. So if 4 consecutive times the probe fails, then we'll mark it as unhealthy. So this means that after 4 consecutive, I'm very terrible at spelling, so please do not mind that. After 4 consecutive, what did I say? Unsuccessful probes, or yes, after 4 consecutive unsuccessful probes, the pod will be marked as unhealthy. I think the spelling of consecutive is wrong. I would assume this is the right spelling. I'm sorry if it is not. Then similarly to failure threshold, we have this success threshold. So success threshold basically means that, let us say if it was 2, then if the probe is successful 2 consecutive times, then the pod is healthy. Default is 1, we'll keep 1 only. So let us say successful after 1 successful probe. So these are all the keywords that we can use with our probes. I think it is good to go now. So we'll simply apply this. Before that, let me also set alias so that it's easier for me to write these lengthy commands. Clear. Now let's apply this YAML manifest, and the pod has been created. So quickly we will do kubectl get pods with -w. So we'll have to wait for a few seconds. For now, we can see that the status is running and the restarts are 0 here. Let us wait for 30 seconds because we know that after 30 seconds, the pod should be unhealthy because the file will be or the folder will be deleted. I think I have waited for quite a few seconds, but there is no change. Let me describe this. Spelling is wrong. It's not live, it's live. What has happened till now is that the image was pulled and then the liveness probe failed actually because there was no such file or directory, and then the probe again failed here and the pod has been restarted once. So we are doing the same thing again. The container will be created, the container will be started, and it is for now successful. So if we look at kubectl get pods, we can see that there is one restart here. So why is it so? Because because the liveness probe failed once, and once it failed, why it failed? Firstly, why it failed? Because 3 consecutive times we did this cat command, and it said it gave an error basically that no file or directory exists. So this happened for 3 consecutive times, and after that the probe failed. And once the probe failed, the container was restarted. If we do kubectl get pods again, you'll see that it has failed twice and it has restarted twice. I think that is it. It will keep on failing and it will keep on restarting. So this is what we wanted to discuss with the exec liveness probe. Now let it run. Let us see how many times it restarts. We'll look into it later. Let's for now move to the next type of liveness probe, which is HTTP. So HTTP liveness, quite similar to the previous one. We have already discussed all these in the theory videos, what these things are, what these types of probes are, and what are exec probe, what are HTTP probe, what are TCP probe. So maybe if you haven't watched that video and you don't know about these things, so you can watch it there. Otherwise, it's all good. So now we'll create another file. Let's call it liveness. And for now, we'll call it http.yaml. We'll paste the content. And if you look now, what's happening is the name is liveness http. We have this image here. And if you look at the arguments, there is just liveness, and the liveness probe, what it does is it will use http get, and we are specifying the port to be 8080, and the path is healths. Basically what liveness probe is will do is it will go to this particular path or this particular route, and if the response is not an error, then it's good. But if it gives an error response, then the container will be, or the pod will be, marked as unhealthy. So that's what it does. I think we should also look into the documentation for this. So here it is. The source code basically is something like this. We have this uh, so for this route we have a function handler. If you are familiar with Go, then it's easier for you to understand. Otherwise, I'll break it down for you. So for the first 10 seconds, we are saying that the header should give you, like, it should give you a response called okay, and the response code should be 200. So the response goes works fine. Otherwise, we'll show the status code to be 500. So there is some internal server error basically. So what happens is for the first 10 seconds, it works fine. And after 10 seconds, it will give you an error. It will print this error. I think that is it. So let's go back to our terminal. And like we discussed earlier, we can also have more keywords here, but for now, let's keep it simple. Let's exit and let us apply this file, and the pod has been created. So our previous pod, which was liveness exec, has now been restarted 5 times and it still runs. For the new pod, the container is still creating. Let's check again, and it is running. So let's do kubectl describe pod liveness http, and we can see that the image was pulled, and then the container was created, container was started, and then after some time it failed as well. So it has failed 3 times over 11 seconds. So it gives us a status code called 500, and then after that it says container liveness failed, so the pod will be restarted. So the container has been restarted. Let us now check kubectl get pods, and we'll see that there has been 3 restarts. So that is basically how it works. Let us try the same thing with a TCP liveness probe as well. It will be quite similar. So this is the file for TCP. Let us go back to our, okay, I don't know what opened, sorry. Let us go back to our terminal. And now we will create another file. Let's call it liveness, liveness tcp.yaml. And let's paste the content here. So if we look into the content, we'll see that we have this name of the pod as go proxy, and the container is go proxy, and we can see that the port 8080 has been exposed, and we have two probes here actually, the readiness probe and liveness probe. So in the readiness probe, it is simply saying that this port, it will try to access this port, and if it can access this port, then it will be, the pod will be healthy, otherwise it will not be healthy, and the container will be restarted. This is for readiness probe, and the liveness probe does the same thing. These are pretty much the same. Initial delay seconds is 15 seconds. So for the first probe will be conducted after first 15 seconds, and every 10 seconds the probe will keep on repeating itself. So I think it is quite straightforward. We can simply apply this. If we say kubectl get pods, then the previous pods, if you see the HTTP one and the exec one, these have been restarted a lot of times. This has gone into crash loop back off. After some time, it will be running status, and this will keep on repeating. If we describe the HTTP pod, the liveness HTTP pod, we will see that it was successful, and then it was again failed, and then container liveness failed again, it was restarted. So I think it has been restarted 6 times, and it has gone to this back off restarting field. So if we say kubectl get pods again, then both of them have now gone to this crash loop back off status, and after some time it will again the probe, as soon as it fails, it will restart the container again, and it will come back to the running status. So if you look at this go proxy, it is in running state. Let us say kubectl describe go proxy. Sorry, I did not mention pod. And it created a container called go proxy, and it started this container. And since we have exposed that particular port, so it will always be healthy, and since it is healthy, then it will remain like this only, and there will be no container restarts. So this was basically about the liveness probe, and we also saw one example about the readiness probe. I think liveness probe is quite clear now, because we have done like 3 examples of it. Now let's create a deployment where we will have this pod, and we will also connect it to a service, so that we can really see how this readiness probe works. So what we will do is we'll create a configuration file. Let's call it depl.yaml. I think we can do one thing firstly. We can use kubectl command for the basic template of the deployment. So kubectl create deploy, and then I don't remember the command, so I think I'll need some help. So the command is kubectl create deploy, name of the deployment, let's call it readiness. Let's call it readiness deployment, and then image Let's use this HTTPD image and anything else. Port. So we can specify port here. Let's say 80. And we would want to do this dry run as client. We would want this output in format of YAML, and we'll take this output and we'll paste it to our dpl.yaml. So now if we say dpl.yaml, I have this. Yes. So clear everything and let's go to depl.yaml, and we have this content here, which is good. So I would want to delete some stuff here, which is confusing. So let's remove this. Labels, I don't think we need. So we'll remove that as well. So we have these things. We have the name of the deployment. And then let's go to the spec part. Let's say replica is one. Okay, fine. Selectors, match labels. This is the matching label for us. Strategy, I don't think we need it. Again, this creation timestamp, remove this. And labels here is this thing, which is fine. And then the containers part is here. So we are using this HTTPD image. We have to specify the port, which is here. So port is 80. Resources can be deleted. This also, let's delete it. And now let's write our readiness probe. So readiness probe, and we'll use HTTP get the path. Let's keep it this, the root. Okay, I think readiness probe, and then this should be here. But the path is part of HTTP get, right? So it should be this only. Path is here. Then along with path, we would need this port. So port is 80. I think it is correct now. And then we'll specify those keywords. So no, not here. They here. It should be here. Initial delay seconds. Let's keep it as 15. So now we'll give it 15 seconds to get ready. And every 15 seconds, we will run a probe. And I think this is good to go. Let us close this. And let us also create a service. Actually, we can also create this manifest for the service in this file only, but I'll need a template first. So we'll create a new file. Let us say svc.yaml. Let me use a template for this. So kubectl create service, and the name of the service, let's call it readiness svc. And I don't think we need anything else. We can write it on our own. Dry run is equals to client. Spelling of client is wrong. Where is the cursor? What else? Output should be YAML. It should be taken and pasted to the svc.yaml. Maybe something is wrong. So I have wasted a lot of time in creating a service through this, and I think rather than doing this, I can simply write a service on my own. So let me now simply write it. It was called SVC, I guess. Yes. So we'll write it on our own. Firstly, we'll start with API version, which should be V1. Then there is a technique I have mentioned in previous videos as well, which I use, which is like AKMS, so that I don't forget anything. So AKMS is like a mnemonic. So A for API version, A is for API version, then K means kind, and M means metadata, and S means spec. So kind will be service, metadata will be this name, let's call it readiness SVC, and we will need a selector which will be used for matching the labels, and I do not remember the labels we had with the pod, so I'll have to first check that. So the labels are here. These are the labels. Let me clear everything. Clear. Go back to our SVC. They should be like this. And what else do we need? We will need a port. Ports, which is a list. So port will be 80. I think it was 80. Let's keep it 80. And then target port will be 80. Type also should be mentioned, so it should be cluster IP. I think P should be capital. Let us see. So let's apply this YAML configuration, and the service was created. So there are a few extra services, but the service we created right now was Readiness SVC. This is the one. Now we can also apply our other configuration, other YAML manifest, which had our deployment. So the deployment has also been created now. DEPLOY. So it has been created. It is not ready yet. kubectl get pods. And the pod that we created was this one, and it is in running state. It is not ready yet, and the deployment is ready. With that, our pod is also ready. So if we now want to, since the pod is connected to the service, we can check the service endpoints. No, get endpoints. Name of service was, let me see, it was Readiness SVC. Let me zoom in. And we have this endpoint. If we look at our pod, then so we can find this endpoint here, this 10.244.2.11. So the pod that we had also has the same IP, 10.244.2.11. Why is this so? This is because since the readiness probe passed, then after that the service this pod was added to the service endpoints. If the pod was failed, then it would not have been added to the service endpoints basically. So how can we ensure that? Let me say kubectl delete the deployment, which is this one, and let us create it again using this, and we'll quickly say kubectl get endpoints. The name of the service was this and dash w. So right now you can see that there is no endpoint. Okay, so now we'll wait for some time, and after the probe will basically pass, the probe will, yes, the probe has passed the pod, and the probe says that the pod is healthy, and as soon as the pod was said okay, this is healthy, then it was added to the service endpoints. And like we discussed in the previous video, that is what readiness probe does. It will not let the service access the pod immediately. It will first ensure that the pod is running, and after that, once the pod is running, then we will apply this probe that if it is healthy or not. Then if it is healthy, only then it will be added to the service endpoints. If it is not healthy, it will be marked as unhealthy basically. So this is how we ensure that the endpoints, basically this pod will not receive any traffic until it is ready, and if it is not ready, it will never receive traffic. But if it is healthy, then it will receive traffic, because it will be added to the service endpoints.